again. Hello everybody. Now I'm in the front of you like engineer, company working in Brussels, and I want to mention the fact that from professional point of view it was a great experience because I finished more than 6 contracts, and 4 of them are passive house and special buildings which can achieve with this eco design requirements, and there are really a very nice experience. Together with Maria, we also were preoccupied by the refurbishment, the deep refurbishment of building and the refurbishment of building. And one of this example is Théâtre Real de la MONNAIE, is the Royal Theatres in Brussels, for which we done the heating system, we renew the heating system and the cooling system. And I want to share with you some experience like engineer for this work. The building used for workshop and administrative services at the Théâtre Real MONNAIE in Brussels was subject to complete renovation in an effort to make the work condition for the administrative and technical staff at the theatre more comfortable and the building more conform to the fire safety regulation and more energy efficient. The building is situated in the downtown of Brussels. There are in fact 2 buildings, and the works are supposed to have 2 stages. The first stage is the administrative building, and the second stage is the Théâtre de la MONNAIE. Between them will be built a tunnel which connect the both building. The building separate from the theatre itself has 2 very different facades. A neoclassical one at 23 Rue Leopold and a modernist one at 41 Rue Fossé-Olu. The objective of energy efficiency was achieved by renovation of the infrastructure of installation, central heating and cooling, water supply, sewage and gas pipe, electrical power and control of equipments for fire detection, lighting and building management system integration. 2 major areas were assigned as utility rooms in the basement and the boiler room on the roof to the 1st floor. The hydraulic scheme, the hydraulic heating scheme, supposed to have the boiler rooms with 3 rooms with 3 boilers for heating, the main distribution, the collector and the main distribution for collector, a boiler for domestic hot water, and 2 substations for heating for the administrative and the office, and a substation for domestic hot water production. The cooling system is supposed to have a chiller and 2 dry coolers. I will detail in my presentation. The phase 1, the boiler room on the top of the building. It was a structure, a metal structure for this boiler house. We have we have 3 boilers or 850 kilowatt and 1 boiler is 100 kilowatt for domestic hot water, how I said before. The main heating water distribution in the boiler rooms, the pressure maintenance system with the compressors, back of boiler gas supply, gas exhaust, water supply and return fresh air intake. Cooling system, 2 dry coolers on the roof and water chiller in the basement. and the building management systems, which are the system providing integrated management of the technological function of a building: heating, cooling, access control, security, fire alarms, lights. It can be accessed by remote by the administrator from any location for modifying different parameters. We have some slides which show the building management systems, the 3 boilers, and the parameters which can be monitoring every moment. Also the heating diagram, a boiler from the domestic hot water, and the main distribution. The heating diagram, hot water tank and domestic hot water supply. It's a system with 2 heat exchanger who produce instantaneous domestic hot water. And the heating diagram supply for administration office, and how we monitoring the temperature and the pressure in the systems. And also the heating diagram supply for the workshops. Here to the right side we have reserve distributions. Regarding the cooling, the 2 dry coolers and the water chillers, how it's monitoring in the building management system. In fact, the cooling system supposed to have a cooling water chiller from 300 kilowatts, and 2 dry coolers, 195 kilowatt per pieces, together with the water chiller from the lowest floor on the basement. When choosing the optimal solution for the heating concept, 2 solutions were discussed. The version 1 was gas condensing boiler, constant speed pumps, hydraulic pressure separator, or version 2, gas condensing boiler with high water content and variable speed pumps. The second solution was implemented due to the high energetical efficiency. How I said, the condensing boiler with the hydraulic pressure separator and constant speed pumps. And here are the boilers with a high content water, 800 liters of water in each boilers, and pumps with variable speed. That was the first part in which I show how we decide the solution to improve the energy efficiency of the systems, and how the building management system can monitor the systems. And important things from the engineering point of view, it's that we put a Mercedes, which is the heating plant, the boiler plant, in the old system. We have different heating system, radiators. We have air handling units, but older than 40 years, and that you will see should give a problem in function after put in function the new boiler plant. The issue of water property in the heating systems. The design indoor all distribution versus new boiler plant. It's what I mentioned before. Design requirements. Washing for the system washing facility with 3 sodium phosphate as a protective film against corrosion. Measuring and controlling pH, hardness, conductivity of water. Requirement suppliers of boilers. Low conductivity of water resulting pure water. Filling the entire heating system old, the theater distribution, and new boiler plant and main distribution with demineralized water. It is contrary to the design requirement, thus removing the protective film of trisodium phosphate submitted to washing in order to prevent corrosion. We can see here the conductivity for the boiler which is required by the boiler suppliers should be less than 20 microsiemens per centimeters. We have a bulletin analysis of the water, and the conductivity we can see here it's 1038 microsiemens per centimeters. How it's possible to achieve this requirement of the supplier? This is the question. The main observation. The conductivity is determined by the presence of the salts, by the presence of the sodium or sodium chloride used to regenerate the ion exchanger cations. The softening installation does not alter the conductivity of the water because there is only one exchange of calcium ions with sodium ions by the ion exchanger. Therefore, the conductivity cannot be less than 800 microsiemens per centimeter unless you mount a new stage of water purification, reverse osmosis station. In this case, the conductivity drops below 80-90 microsiemens per centimeter if you mount an installation of two-stage conductivity can be less than 10 microsiemens per centimeters. That means only if we will have reverse osmosis in two stages, we can achieve the requirement of the boiler suppliers, which to have an osmosis reserve osmosis station, that means other MONNAIE, but the main issue is what will happen with the old systems versus the new boiler plant. I can tell you we have pressure loss in the system because it's an old system, and 1 week per month we have some problem, and we should fulfill the systems to take the pressure constant. The presence of phosphate in the installation is caused by the trace of trisodium phosphate used in the phase of flushing out the heating system. The presence of phosphate ion is useful because it determines the formation of coating of iron phosphate on the inner surface of pipe and heating elements. This layer has a role of protection against corrosion. The presence of ion of calcium is softened in softened water can be determined by incomplete rising of the ion exchanger after the stage of regeneration or the exhaustion of ion in the column. In any case, calcium ions are no longer present in the system through the formation of insoluble calcium phosphate in water. They are deposited in the installation, but the amounts deposited are very small, than tens of milligrams per liter of water introduced into the installation. This is my experience, and from the building services engineer, I should become a chemical engineer to solve this problem. In fact, it's the requirements from the boiler supplier and the designer are in contradiction. And let's have the first question: how to solve this problem for the future if we refurbish such of system in the old building. Thank you very much for your attention.
Thank you.